We defined physics already as the study of matter, the study of energy, and the interaction between matter and energy. And we talked about these different realms of physics that we touch upon in Physics 20 and in Physics 30. We said in Physics 20, it's mostly mechanics. It's mostly questions like, you know, your car is driving towards Calgary at this speed. How long does it take to get your car there? Maybe the surfer is riding a wave off the coast of California. Okay? How long does it take the surfer to come in, or what's the height of the wave, or what's the wavelength of the wave, or something like that. Okay? The roller coaster is going around a loop, a vertical loop, an upside down loop. How fast does the roller coaster need to be moving in order to stay on the loop without falling off? That's the kind of thing that we do mostly in Physics 20. We're going to start off Physics 20 with a realm of physics that we call kinematics. Kinematics is the study of motion. But it's not the only realm of physics that talks about motion. Kinematics specifically is the study of motion without regard to what causes that motion. In other words, who could tell me? I was going to answer this question for you already, but I'm going to ask you. Who can tell me what causes motion? Anybody know the word that I'm looking for here? Yep. Work. You're close. You're close. It's the term work is intertwined with the term that I'm looking for here. If you've talked about work already, you've learned about work already with where you went to school before, you'll know exactly the next term that I'm about to mention. You'll know exactly what it means. Force. Yeah, force. Force is a push or a pull, right? Kinematics is a study of motion without regard to what causes the motion. In other words, it's a study of motion without regard to forces. We're going to pay attention to the motion itself, and right now, we're not going to pay any attention to what caused the motion, the forces that caused the motion. That's coming. Okay, we're not just ignoring that completely in Physics 20, but that comes after we learn about some basic motion. Study of motion without regard to what causes that motion. Going to define a couple new terms now. Not new to you, not new to most of you at least, because you would have learned these in Science 10, but it might have been a while since you've seen this before. A vector and a scalar. Who can tell me what the difference between a vector and a scalar is? Who remembers from Science 10? From Science 10 or some other course that you've taken, right? Go ahead, Rosie. Kinda. Good. Magnitude and direction. What do we mean by magnitude? It's an amount, right? An amount. Now, a vector can be something like displacement. Talks about movement. Can be something like force, something like momentum that we talked about in Physics 30. A vector is something that has magnitude, an amount, and direction. Whereas a scalar is something that only has the amount. There's no direction associated with it. So Edmonton is 350 kilometers north of Okotoks. That's a vector description of where Edmonton is. Edmonton is 350 kilometers away from Okotoks. That's a scalar description of where Edmonton is. That make sense? I'll tell you a little story. Years ago, I went grocery shopping with my wife. I hate grocery shopping. Okay, I hate grocery shopping, but especially back before we had kids, a lot of times we'd go out together grocery shopping. I was at No Frills. It wasn't called No Frills then. It was a different grocery store then, but what's now No Frills. And sometimes when my wife is shopping, when my wife is pushing the cart and putting stuff in the cart, and I, just put whatever you want in the cart, and I just do things to entertain myself sometimes. Like sometimes I watch people, and I kind of just look at odd things that people do. People might do the same to me because what I'm about to tell you might sound a little odd to you. This one night I remember I was at No Frills, or what's now No Frills, and I'm in the cereal aisle of the store. And I'm walking up and down the cereal aisle, and I'm picking out cereal boxes, and I'm reading them. I'm reading the ingredients and the nutritional stuff on cereal boxes, not because I wanted to buy cereal, but just because, I don't know, I passed time reading cereal boxes. And then I noticed one box of cereal It's called vector serial. Actually, they call it a meal replacement. Vector meal replacement. Anybody ever had this, by the way? Yeah? I've never actually eaten it. Is it good? Yeah. But when I saw it, they used to market this as meal replacement, right? It's not cereal, it's meal replacement. But to me, it looked an awful lot like cereal. So I thought, I'm going to read the label. I'm going to see what exactly is in this vector meal replacement that separates it from cereal. What makes it different than cereal? There's not a whole lot, by the way. It's pretty much cereal. It's pretty much the same thing. But what I noticed about it was something that I hadn't intended, something that I hadn't been looking for. When I'm looking at the side of the boxes, I noticed that every other kind of cereal, every single cereal in the aisle, except for vector cereal, had a front that looked like this with the name of it and some marketing stuff, a picture on it, and then at the bottom it has 400 grams or 600 grams or the magnitude of the size of the box, right? The magnitude. That's an amount, right? 400 grams is an amount. That's how much cereal is in here. It doesn't show direction. It's just an amount. Every single cereal box has that amount on it. Every single cereal box has a magnitude of the mass of the cereal that's inside it. But vector cereal, if you turn it to the side, and I thought this was kind of funny when I saw it. Turn it to the side, vector cereal is the only one that says on the side of the box, directions for use. Now, if you ever wondered how to eat cereal, vector cereal would be the kind of cereal to buy because they tell you how to eat it. Let me read it to you. Place 55 grams of vector in a bowl. Now, I assume you could vary that a little bit. 52 grams or 58 grams would probably work as well. Then it says, add milk. Place vector in a bowl, add milk. Then what? Doesn't tell us what to do after that. Get out, spoon, eat. Doesn't tell us what to do after that. Listen, that's not a direction like north, south, east, west. It's not a direction like we're talking about with vectors and scalars. But it's a way for us to remember the difference between a vector and a scalar, right? Every other kind of cereal has magnitude only, 400 grams. Vector cereal has magnitude, 400 grams, and direction on the side of the box, even though it's not the direction we're looking for. Again, it's a way for us to remember that vectors have magnitude and direction. I thought that was so funny that I bought the box of cereal that night. This is it. I can't remember exactly when that was, but I will tell you that this cereal expired on November 13th, 2003. So if you were thinking about stealing my cereal, go ahead. See what it tastes like after having been expired for 12 and a half years. Vectors have both magnitude and direction. Scalars have just magnitude. Magnitude only. Scalar cereal, cornflakes, they don't tell you how to eat it. Cornflakes doesn't give you direction. That's a scalar. Vector cereal is a vector. Magnitude and direction. This is a reminder, right? Vector cereal, magnitude and direction. Now we're going to talk today about three different terms, three different types of quantities, vectors or scalars. We're going to talk about what they mean. We're going to assign a symbol to them so that we can abbreviate it, not write down the word distance every time. The units, and we're going to identify it as a vector or scalar. And then we're going to figure out how to find out the value of these terms, these distance, position, and displacement. Distance we can define in a number of ways. The easiest way is to say quite simply, it is how far something moves. How far something moves. The distance between Calgary and Edmonton is 350 kilometers. So if a car drives from Calgary to Edmonton, it's 350 kilometers. Rose, in the UK, you've probably traveled across like 2 countries, 3 countries, if you drive that far, eh? In Canada, you're a third of a province. You've traveled about a third of a province. My son had hockey at Staveley yesterday, which is about 50 kilometers away. We drove 50 kilometers. Okay, that's the distance that we traveled yesterday. Sorry, it's about 75 kilometers. Times 2, because you got to come back, right? How far something moves. The symbol for distance is delta D. It's a symbol. What's the symbol delta mean? Yeah, good. Change. It's a Greek letter. It means change. So change in D. Changing where you are. How far something's gone, changing where you are. The units for distance, we can use a whole number of units, a whole vast array of different units, but the most common one and the standard one is meters. We could also use kilometers or centimeters or millimeters, depending upon the context. But again, the most common one is meters. Distance is going to be, anybody want to take a stab at this, a vector or a scalar? Does direction matter? When I drove to Staveley yesterday and back, my total distance traveled was 150 kilometers. Is that a vector or a scalar? Scalar. Okay, scalar. Now, which way I went mattered, but not in the way I just described it, right? The way I just described it, the direction was irrelevant. The odometer on my car said 150 kilometers more than when I started. Okay, distance is a scalar. Position. We're going to define position as where something is. Where something is. Where is something? Where is something? Where's Calgary? Well, downtown Calgary is about 45 kilometers away. It's 45 kilometers north of Okotoks. Listen, if I want to know where something is, it's not good enough to say Calgary is 45 kilometers away. That doesn't tell me where it is, right? If you want to go to Calgary, and I say Calgary is 45 kilometers away, how does that help you? Hey, I got to say it's 45 kilometers north of Okotoks. That's the position of Calgary. It's 45 kilometers north of Okotoks. Where's the position of McDonald's? It's about 4 kilometers south of the school. Right? You want to go for lunch, you want to know where McDonald's is, you better have direction associated with it so you know which way to go, right? The symbol for position is a D with a little half arrow over top of it. What do you think that means? The little half arrow. Yeah. It means direction. It has a direction associated with it. Therefore, it's going to be a vector. The units for position are meters as well. Displacement. We're going to define as the change in position. The position of the Dogs Stadium at the bottom of the hill, the baseball stadium at the bottom of the hill, is 2.5 kilometers south of the school. The position of McDonald's is 4 kilometers south of the school. If you went from the Dogs Stadium to McDonald's, your change in position is 1.5 kilometers south. Does that make sense? Okay. This is where you were at the Dog Stadium. This is where you are at McDonald's. Your change in position is one minus the other, 1.5 kilometers to the south. So the symbol for displacement, it's going to have D in it because it's change in position. What's the symbol that we usually assign for change? Delta, the Greek letter delta. Delta D. It's almost the same as distance, but it's got that little half arrow over it to tell us that it's change in position. It's displacement. It's not distance. Units are going to be meters, vector, or scalar. Vector, scalar. Vector. Has a direction associated with it, right? Good. Let me give you a quick example. I'm going to go for a little walk in the classroom here, okay? Just back and forth along this axis here, okay? We're going to use the front wall as our reference point. So that's 0. Right now, excuse me. Right now, excuse me, I'm 2 meters north of the wall. What's that? Is that a distance? Is that a position? Or is that a displacement? I'm 2 meters north of the wall right now. Yep. Is your hand up? Oh, well, that'll teach you for moving your arm a little bit, right? You're going to answer that question for me anyways. I'm 2 meters north of the wall. Distance, position, displacement. That's going to be my position. Just wait 1 second here, everyone, okay? That's going to be my position. Okay, now I'm going to walk. I'm going to say, remember that number? I was 2 meters north of the wall, right? 1, 2, 3, 4. Where am I now? 6 meters north of the wall. That's my distance, position, or displacement. That's my position. What's the distance that I just traveled? No, not 6 meters. I was at 2 meters. Now I'm at 6. Now it's 4 meters. That's my distance. What's my displacement?
4 meters north.
Good. 4 meters north. Got it? Distance and displacement, the exact same value right there. Do 1 more second here, guys, and then I'll let you go, okay? Distance and displacement, the exact same value there. Let's start this again. 2 meters north of the wall. Now I'm 6 meters north of the wall. Now I'm 5 meters north of the wall. When I went from 2 meters to 6 meters to 5 meters, what was my distance that I traveled? What was my distance? I went from 2 to 6 to 5. Distance was? No. Distance was 5 meters because I went 4 and then I went 1. Didn't matter what direction I went, right? I went 4 north, 1 south. Doesn't matter what direction. Distance is a scalar. What was my displacement? Remember, I was at 2, then 6, then 5. My displacement is 3 meters to the north, right? Distance and displacement are the same value when we don't change direction. I kept going in the same direction, distance and displacement, the same value. But as soon as I changed direction, distance and displacement had different values, right? So you can see why sometimes it's really important that we include direction, whereas other times it's not so important that we include direction. All right?